Hi, I'm Wojciech. I work here at Software Motion, as mentioned. And for the last 2 years, I've been working on cool multimedia projects like Membrane and LiveCompositor. And right now, I will be talking about uphill battle of replacing Headless Chromium, especially for server-side video rendering and audio mixing. So what do I mean by that? The first part is pretty self-explanatory, server-side. But what I mean by video rendering and audio mixing. So basically, we have two use cases. The first one, we have one stream, and we add some overlays to it, something like a banner or a logo. Or we have multiple streams, and we combine them together. So why do you want to do that? So let's explore the first use case. We have something like SFU, video conference, where each participant sends their video to the server, and server forwards videos to other participants. And right here, we don't need any rendering on the server side because the video is rendered in the browser on the client side. But if we want to somehow record this video or export it to HLS, stream it to Twitch or YouTube, we would need some way of combining those videos together. And out here in the architecture, the best place to do it is on server. This is just one use case. There are plenty of more. For example, if you are running something like Twitch for developers, you might want to add an ad banner on your stream that isn't blocked by ad blocks. You can add something like sign language translator to the real live stream. You can have something like sport match where you want to add a banner with current score. But I will leave the job of figuring out $1 million startups for you and focus on how you actually do this. So I know what all video tech engineers sitting out here think at this moment. Just slap some FFmpeg and GStreamer and call it a day. While those tools are great for like transcoding video and changing the formats and so on, when it comes to the video rendering and mixing the video, they have pretty limited capabilities. You can only choose stuff like where you want to put this video, and you can't do really much about else. You can't do any like animations, change dynamically where video is located. So what most people end up using is some headless browser, something like Headless Chromium or Electron that runs the Chromium under the hood. And here you can render anything the browser can render, which is great. But as Dan Jenkins said on the last RTC.ON, and with the great power comes the great responsibility. So the Chromium has few drawbacks. To start off, you have to somehow deliver the stream to the Chromium. And to do that, you need to use a protocol that is browser compliant. So you'll likely end up using something like WebRTC, which for SFU use case, it's totally fine. But if you're using something like broadcasting, then adding WebRTC in the middle of it might not be the thing you want to do. Also, it's pretty hard to synchronize those streams. It's pretty hard to tell by the WebRTC at which timestamp each stream should start, and things like that. Also, deploying Chromium isn't as pleasant as it might be. The repo itself is 3 gigabytes, the binary, and it has a lot of dependencies. When it comes to the performance, the fact that you are using Headless Chromium doesn't mean that it doesn't want to eat all your computer resources. So there's a room of improvement there. And if you think about it, the HTML is not really designed for statically sized websites. So when you want to render a video, you have strictly set size, like width and height. But websites are mostly scrollable. So even if you know HTML pretty well, it doesn't mean that you will be able to write what video you should render without any issues. And noticing those issues, we ask ourselves, is it really the best we can do? And this is how we came up with the idea for LiveCompositor. So what it is? It's a media server written in Rust, which receives some input stream by simple protocols like RTP or MP4. We'll add more later on. And it renders the video and outputs them back. And you configure it with HTTP requests. So you say for it something like, this stream will be coming to this port with this protocol, and I want that stream on that output port with that protocol render with something like this, and you can change it dynamically, so you can update the video that you are getting on the fly. So let's explore the HTTP API we got. I won't bore you to death with basic configuration. Instead, I will explore what you can actually render and how you specify it. So we start with something simple, like empty div. The view is like our component for div, same as in React Native. And here we add a first component, a shader that replaces a green screen. So as a child component, it takes an input stream that has a green screen and replaces it with an image. So while there are many built-in components in LiveCompositor that you can use without any knowledge of how GPU works and so on, if there is something lacking, you can always write your own shader, register it, and use it like here. Next up, we'll be adding Big Bag Bunny. So after the shader component, we add a rescaled input stream, pretty simple, pretty straightforward. Next up, we are adding a bar on the bottom. So again, some view, you can call it a div, with some parameters set there. There is no width height set, so the width is the same as the parent component. We set some color to gray. And now we're going to do the hardest thing in HTML ever. Any guesses on the room? What would it be? Yeah, right, centering a div. So we want to add a text on this bar that is centered. So we add 3 children components, 2 empty divs and the text, and it works the same way as in Flexbox because the width and height are not specified, so you get the center text. So we ended up with something like this. While the configuration, if we go step by step, is pretty easy to come up with, it's not perfect. To start off, it's quite lengthy. It's hard to read when you got a lot of components. And it's also not easy to build something really dynamic when you are having something like chat overlay and it changes. You have to keep track of all of the state. So to solve that issues, we started working on TypeScript SDK. And we thought that we could write something like React, and you would be able to use React for your live streams. So we start off with JSX components. So this is the JSON that we had earlier, and this is the JSX, and that is similar to it, basically the same. That does the same thing. So while all the information is here, it's really more concise, more compact, easier to read. But it doesn't solve a problem of dynamic components. So let's create one. We start simple with just Big Bag Bunny with some overlay text. Out here, we have our view component, rescaled input, and some view on the bottom with some text displayed there. So we get something like this. Yep. So let's add a new streams with some animations. So firstly, we start up by exporting the previous logic to the component, as you would do in React. And then we use hook. This is a LiveCompositor hook. You just use it by importing it. And it keeps the state of the input stream. So if you use it in some components and the state of the inputs changes, for example, some inputs start receiving data, or we get some inputs removed, added, React knows to re-render those components. So we return tiles component, which is something like grid, with mapped inputs, and based on the video state of the input, we either return input tile, which is the component we've defined earlier, or some image GIF with spinning wheel that we have to register earlier on. So you get something like this. Okay. You can also use regular React hooks. So let's display new stream animation, new stream notification when new stream joins. So this is pretty much the same code as earlier. We just wrapped the tiles with div and added a new component that we're going to implement next. And there's a lot of logic out here. You don't have to understand all of it. I just want you to focus on that we keep the track of the last added stream, and based on that, we display either a text with a message about the stream or nothing for 3 seconds after the stream is joined. And you do it the same way you would do in React. So you get this notification above when new stream joins. So how it works under the hood, because I was going on and on about Chromium is bad, but now I'm bringing a React with what God knows what up here. So it turns out that you can use React without using the HTML, the browser, because React is not the same as React DOM. While the first one gives us state management and stuff like use state, use effect, ability to build components, the React DOM is responsible for translating the nodes of the virtual DOM to actual nodes of the browser DOM. And the great example that you can use React without using React Native, without using browser is React Native, where you have basically the same logic from React. And if you write for native platforms, you don't end up having a browser running on your native device. This is translated to native components. So the same way LiveCompositor SDK does it. Here we have a React part that users will write, and under the hood, it just spawns a LiveCompositor server written in Rust, and it communicates what it needs to do with HTTP API, and it gets a notifications like new streams joining, changing the state back from the server via WebSocket. Obviously, there are some drawbacks. To start off, it's new API. Because we are not using the browser to render for rendering, you can't just put like random div in the middle of it and expect it to work. Same, you can do it in React Native. Also, hardware decoding and encoding is still work in progress, and we expect it to be the most beneficial in terms of performance upgrades. Because currently, if you're running on the GPU, most of the work is actually decoding the input streams and encoding output streams. The rendering itself isn't that bad. Also, emulating rendering on CPU can be expensive. If you have a device without GPU, it might be the most expensive part. And also, currently we support only RTP, MP4, and some decklink devices on the input, and MP4 and RTP on the output, and we are expecting to add more protocols in the near future, so you could just pay something like Twitch link, and it would stream directly to RTMP link, and it would stream directly to Twitch or YouTube. So what you can actually do with it, here's like the demo that we did to showcase the possibilities. I think, okay. So this animation was done with like custom shader, and the only part of this demo that isn't done in the compositor is this code is generated by the third party, these animations, but the rest of like swipings, all this stuff is done in the compositor. So you can have pretty dynamically changing rendered outputs, as you can see. Maybe I will split it up. So yeah, you can have animations like those. So, do we have still time? Because the timer started. Okay, I will just show you a demo. Of it doing it in real time. So, here we have the same tiles transitions as we mentioned earlier, but as we see, those tiles aren't as good looking as previously because there's a lot of like empty space out here. So we are going to try to fix it. First thing that you might notice that those inputs are not like regular 16:9, or just 1:1. So let's open up an editor and find something like it. Okay, here we have a component responsible for those tests. So let's take a look what we might add here. Those won't be really helpful, but maybe we can add something like tile aspect ratio, sounds like something we need. Let's check out. Oh, it's written like this, so yeah, of course. And now, right now, when we run it, it should change the aspect ratio. Okay, so we get a little bit better effects there. You can also customize other stuff like the text out there, and so on and so on. So yeah, that's it from me. If you have any questions, I'm happy to answer them. Yeah, sure. Now it's...
Dan has a question. Oh, what license is it released under?
Okay, so for the membrane plugin, we have Apache 2. So if you use it inside the membrane, you can use it for free. For the web server itself, we have business license, and here we have explanations for the reasons behind it on our website. So basically, we wanted to prevent like third parties repackaging, and we don't want to use anything, don't want to do anything like per seat, per instance pricing, anything like it. But at the moment, you have to contact our product team to get a license to use it for production. For no production users, you can just go to the GitHub and use it as you want.
Thank you. You know, doing things on the server is expensive. How do you intend to, make it profitable in a way that you still deliver amazing experiences, completely handled on the server, but also find a way to, monetize it for the company?
Yeah, sure. For example, the LiveKit uses Chromium for recording, right? So they spawn actual browser that renders. If you want to use record your WebRTC call, you ended up spawning the whole browser and recording it. So we hope that with our solution it would be cheaper actually, because it's like customly built for this use case for just rendering live streams. So yeah, if it's profitable for them in their use cases, it's probably will be better with custom built tools like this. And also, you don't have to like do it for every user. For example, you can have something like Twitch stream, and that gets overlaid ad, and the ad is personalized, but personalized for a group of users. So you have like 100,000 users or 10,000 users watching a single stream, and you group them to like 100 groups. So you ended up with a group of 100 users that get ad overlaid for their interests, right? Or something like this. And for a lot of use cases, you can, for some use cases, you have like one instance per many viewers. So for example, if you are doing something like TV broadcast, right, then just one instance is enough.
Would it also work for real-time scenarios? Like, for example, 7x7?
Yes. So yeah, we ended with the latency go below like 100 milliseconds, ideally. So there is actually an option to configure like the buffer length for inputs. It's somewhere in the documentation. Let's get it here. Buffer something. So you can, for example, configure the duration of input buffers. You can tweak like the presets of the decoders, encoders, so you can make it work for real-time use cases as well. Out here we've seen like 2-3 seconds delay between my input from the camera and it being displayed. And this latency, it's not from the compositor itself, it's from getting the streamer pipeline to re-encode the video and send it because it had different pixel format. Because cameras tend to have like BRGB or RGB or something, and we accept regular H.264 with if.
Just on this live streaming aspect, we do have a customer who is using this for real-time use case in production. So it's battle tested in a way. But there are questions. Oh, lots of questions.
It's nice to see someone fighting the Chrome monopoly. But I was wondering, have you measured performance in comparison to Chrome? And what do you have now and what do you expect to have once you have hardware acceleration put in?
Yeah, sure. The comparison itself, we're planning to do that, but we have like rough estimations. We've tested what instances do you need for what configuration of like inputs. It also highly depends because if you have instance with GPU, then you can do really complex rendering, things per pixel pretty cheaply, but the decoding and encoding is a problem. If you have CPU-only instances, then rendering is the most important stuff. So if you have like really complex renders with custom shaders and stuff like this, then it will be the bottleneck and not the decoding and encoding itself. For the exact numbers, I don't have them in my mind, but I can follow you up with like what instances do you need for what configurations of inputs and outputs.
All right, I have a question about the React part here.
Yep.
So I believe like the LiveCompositor is separating the server, and if I wanted to use it with the React approach, do I need to launch it separately? Like
no, actually the SDK handles that, like launching the server and communicating with it. So you just write the React code. I can show you how the whole code looks like. Let me check out. And so, it's not this directory.
So you run it as a server code, like the whole React stuff?
Yes. You run it on, usually you run it on the server side. So for example, here is the code we used earlier. This is the whole. You just spawn an instance. Here with LiveCompositor create. Here you do some stuff like registering outputs, where you specify what you want to get. And where is the part? Oh, and here is the up part with like what you actually want to render.
All right, and if I use the LiveCompositor without React, we could use like a live stream and then just call the REST API to like for the view to change.
Yeah, you just spawn a binary. It's like in the GitHub releases there is binary, so you just as any binary, and it should work.
All right.
And
Thank
you send HTTP requests from whatever language you want.
And one question, one more.
Yeah.
I hope we have time. Yeah, because like it's really interesting, like the whole React approach. And for me, I did know nothing about that, and I feel like if we have this React code is declarative, and if we like know what are we going to receive, like what streams, we can declare some transitions and so on. But if we, for example, manage a live stream, and if we want to like interfere with what we have like in the React code, can we still use the REST API at the same time?
I mean, if you use React, you would just use. Let's take an example. You are doing something like Twitch chat overlay, right? You would subscribe in React with WebSocket to the events coming from like the live chat, and then you would use it in the component like out here, doing something like the view with text. And if you use the use states and so on, React will render those components whenever the state changes. So
Perfect. So I can like set up some callbacks and communicate with the React instance.
yeah.
Live.
So here we have the example with like callbacks. So yeah, you can use more of this stuff.
All right. Thank you very much. That's really cool. Like as for a React dev, that's really nice.
I think that we have at least 2 more questions. One gentleman over there, and then Dan, and maybe there will be more. Who knows? Can you raise the hand? I think that did I see it right that you have a question? The person who is looking for the microphone? No? Then Dan surely rose his hand, so he's confident in asking questions.
I assume other codecs are going to be supported, as well as other inputs as well, like you were saying. And then I just wanted to say, this would be a great replacement for something like StreamYard, right? Like just to give people an idea of what they could replace with this, right?
Yeah, we have kind of a lot of ideas for going forward with the project. Not only like adding new features, new codecs and so on. We're also currently working on like compiling the rendering engine to Wasm, so you can end up running it on your browser. A lot of hardware rendering stuff, hardware encoding, decoding stuff, and so on. So yeah.
If there are any other questions, please raise your hand up in the air. I guess that's it. Thank you very much, Wojciech.
Thanks.